All right, so wrapping up chapter 9, we're sticking with these complex numbers, right? Again, that's just a number with a real part and an imaginary part. We've talked about how to add or subtract. In section 9.8, we're going to look at how to multiply complex numbers. And we actually right now are not going to look at the division, right? We're going to stick with just the multiplication in section 9.8. All right, now the biggest thing with multiplying complex numbers, a lot of this is going to be things that you're familiar with already, like distributing or using the FOIL method. The big thing with multiplying complex numbers is just to remember anytime you end up with an I squared, by definition that is equal to -1. All right, so for example here, if I have a number that I need to multiply outside of parentheses, right, I know whether it's complex or not, I would distribute. So -8 times -2 would be 16. -8 times 5i would be -40i, and that would be all that I could do. All right, but over here, if I do that same thing and I distribute, 3i times 2 is going to give me 6i. But then for my second term here, 3i times -7i, that's going to be -21i squared. And anytime I see an I squared come up when I am multiplying, I'm going to replace that with -1. So that's going to mean this becomes 6i minus 21 times -1, right? That's what I mean by replace I squared with -1. And so this is going to simplify to 6i plus 21, which is right back to another complex number. All right, and that's going to happen similarly for the last two examples here as well. All right, distribute, just remember, when you get an I squared, it is equal to -1. All right, so I'll post those two examples for you as well. This also applies to using FOIL. So we used the FOIL method already when we were multiplying with radicals. The same thing applies to complex numbers. So if I want to multiply two binomials, I start with the first terms. All right, 4 times 4 is going to be 16. Then I go to my outer terms. 4 times -5i is -20i. Then I go to my inner terms. 5i times 4 is positive 20i. And then my last terms, 5i times 5i, that's -25. And then I times I, of course, is I squared. And so there again, when I multiply, right, I'm going to look through anywhere I see an I squared, I'm going to replace it with -1. And so then when I start simplifying here, the middle terms are going to go away. -20i plus 20i, right? Obviously that's going to go to 0. And so this is going to become 16 minus 25, and I'm going to replace that I squared with -1. Right? That means this will become 16 plus 25, and so this actually becomes a real number. Right? There's no imaginary part left, and the product here is 41. Now, make sure you note, and this is thinking about the Chapter 9 test coming up, this is different from the addition and subtraction in the previous section in terms of combining like terms. And so the way that I know that I'm multiplying, right, is by looking in between the two complex numbers. In the previous section, there would be a plus or a minus, add or subtract. When there's nothing in between, it is an implied multiplication, and that's when I want to use my FOIL method. All right, and again, once you understand that method, it's going to work similarly no matter what type of complex numbers you have, right? The only difference is going to be maybe in the simplifying. All right, so we'll look at one more here. First terms, square root of 6 times the square root of 6. We've already learned we can combine a product under the square root. My outer terms, all right, I've got the square root of 6 times -i. Now remember, we like to put the I out in front to show it's not under the radical. So -i times the square root of 6, and I'm going to do the same thing when I look at my inner terms. So I'm going to write this as negative 3i times the square root of 6. And then my last terms, right, negative 3i times negative I, that's going to become a positive 3. And then again, I times I is I squared. Now when I get ready to simplify, I'm going to remember that I squared is equal to negative 1. And so simplifying, the square root of 36 is 6. Now notice I can combine these two radicals because they're the same radical. They're both the square root of 6. So looking at essentially their coefficients, negative I minus 3i is going to be negative 4i. Keep that square root of 6. And then down here on the end, we're going to have 3 and replace the I squared with negative 1. So finally, this will become 6 minus 4i times the square root of 6. And then, of course, 3 times negative 1 is going to be negative 3. And then I can combine those real numbers. 6 minus 3 is 3. And then our imaginary part is this minus 4i times the square root of 6. All right, so again, each one's going to be the same thing. Use the FOIL method. Replace the I squared with negative 1, and then it will just be a matter of making sure that you simplify correctly. Combine your like terms, right? Combine common radicals if you have them. Simplify your square roots if you can to make sure that you simplify as much as possible. All right, now, like I said, we're not going to look at dividing complex numbers at this point, but we are going to look at evaluating powers of I. And again, the main thing that we're going to remember here is because we know that I squared is equal to negative 1, we can evaluate powers of I if we will write our power, right, whatever it is, in terms of I squared. Right? So for example, if I've got I to the 12th power, and I want to write this in terms of I squared, keeping in mind that we multiply exponents when we raise a power to a power. All right, that would be like I squared to the 6th power, because 2 times 6 is 12. Well, then I know that I squared is equal to negative 1. And if I take negative 1 and raise it to any even power, then I'm going to be left with positive 1. All right, now let's do a couple more, and then as always, I'll post the others for you. Now let's talk about what happens when we have an odd exponent, right? We can't just make this an exponent of 2 times something else. So kind of like what we did when we were simplifying radicals, if we have an odd exponent, we're going to start out by writing this as I to the 1st power times I, and then whatever's left, right, will be an even exponent. And when I have an even exponent, then I can write that in terms of I squared, right? If I want to get back to an exponent of 34, multiplying the exponents, right? 2 times 17 is 34. And then I can say, well, I to the 1st power is just I. So this is I times negative 1 to the 17th power. And anytime negative 1 is raised to an odd power, it will stay negative 1. So this becomes negative 1 times I, or negative I. All right, and then remember what you know about negative exponents, right? If an exponent is negative, the first thing we do is make it positive by looking at the reciprocal. So I would write this as 1 over I to the 5th power, and then I would do just what I did over here with an odd exponent, right? I would write this as I to the 1st power, and then what's left will be an even exponent. All right, I to the 1st power is just I, and then if I want to write this in terms of I squared, right, 2 times 2 would give me that exponent of 4. All right, I'm going to keep that I out in front. This is going to be negative 1 squared, right, because I squared is negative 1. And so finally, this will simplify to 1 over I times positive 1, which is just 1 over I. All right, and so again, I will post the rest of the examples for you, but all you really have to remember in terms of evaluating powers of I is to do what you need to do to write it in terms of I squared, plug in -1 for I squared, and then when you simplify, you're either going to get a 1, you're going to get a -I, you're going to get an I, you're going to get something in terms of 1 or -1, I or -I. All right, so again, in 9-7 and 9-8, what you're going to be looking at is complex numbers. So writing things in terms of I, defining real and imaginary parts of complex numbers, solving equations, set real parts equal, set complex parts equal, and then you're going to be looking at operations, adding, subtracting, multiplying complex numbers, and evaluating powers of I. All right, so that's going to give you what you need to complete your homework for 9-7 and 9-8. I want you to do your best to get that homework completed before we meet on Thursday. That way, if you have any questions, you can make sure to get those questions answered. Thursday will be a review day for us, so bring any questions that you have from Chapter 9, and that'll be a review day for us to get ready for the Chapter 9 test next week.